Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue our new series on edge effects. In this clip, we show just one of the many ways that the edges may be all but inevitably different due to the inviolate laws of physics. That is because while most of the web is under biaxial stresses, the edges can only be under uniaxial stress. One of the many results is that the edges may become thicker as a result. I know your time is precious, so let's get started. As we showed in the last clip, up to 80% of your internal rejects and your customer returns may come from the edges. One reason may be biaxial stresses that we will cover in this clip. We will cover other edge effects in subsequent clips. Let us begin with some essential background. Everyone knows that you need MD tension to transport your webs. That MD tension force results in MD tensile stresses almost everywhere. What might surprise some is that CD stresses also exist. Those of you who have taken my award-winning and trademark Web201 class, for example, will know that CD compression exists whenever the web is wrinkled or not flat due to any cause. My students will also recall that CD tension exists at every effective spreader. What we will add in this clip is that CD tension can also result from certain formation in web manufacturing and converting, as well as mere web handling transport, though the details of why are too technical and too involved to cover here. So, the center of the web will be in biaxial stress state with MD tension as well as CD tension or compression depending on the situation. Here we show CD tension that might happen during web formation. However, the edges of the web cannot support CD tension, only MD tension, because there is nothing to pull on that free surface. Thus, the edges are under uniaxial tension while the center is under biaxial stresses. This means that the edges must be different than the center during formation, and this difference may become permanent. So, at this time, you are probably wondering what counts as formation. Well, most of our common web operations do, including bonding, calendaring, coding, curing, drying, laminating, printing, and so on. However, this edges versus center difference is not just during formation. It can also happen in mere web handling transport as well. The easiest product to see this on is netting or mesh. The reason is that the CD strands or woof have very little resistance to compression before they buckle. The result is that as the net goes through the machine, mere rollers, it necks. However, the necking is not uniform. The necking is more pronounced at the edges. This is easy to see because the CD pitch between the MD strands changes, but mostly at the edges of the web. The result is that the thickness gets heavier at the edges as the web proceeds down through the machine. However, This physics is not only showing up on netting and mesh, it can also show up on any limp material. By limp, we mean low modulus, easily yielded, tender, and so on. So, anyone involved in product process design, or anyone involved in troubleshooting, or anyone involved in QA or customer support would want to know if you can fix the edges somehow without having to trim them off. The answer is unfortunately not usually. Some special spreaders, such as tenters and edge pulls, might do this on some very special webs. The paper industry can also solve this by felting their web runs through the dryer section. However, this costs tens of millions of dollars to make the edges of the web a bit more like the middle. Thank you so very much for joining me in this Edge Effects mini-series. Please join me next week where we will continue our discussion of edge quality challenges by talking about air entrainment. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.